Yo, what's good, Algebra Squad? Welcome back to How to Algebra. Today we're diving into horizontal transformations, that is, shifts, stretches, shrinks, and reflections. Shifting the graph left or right happens when you add or subtract inside the function. A plus moves it left, and a minus moves it right. For a horizontal stretch, multiply a number between 0 and 1, and for a shrink, use a number greater than 1. Simple as that. If you want to reflect it over the y-axis, just multiply the x by a negative number. These tricks will have you mastering graphs in no time. So let's get it. All right, hopefully everyone had a chance to check out the vertical transformations. This is going to seem oddly the same, just slightly different. All right, so again, we have our exploring the horizontal transformation. We have a function here that is defined using this table, and we're going to transform it horizontally in the horizontal transformation or in the horizontal direction. So let's start. Again, I'm not going to complete the table. We don't need to explore here. We just need to know what the transformation does. We're looking at f of x plus 2. So notice that x plus 2 is inside the parentheses, right? Inside the parentheses. When you have a transformation that's happening with the x inside the parentheses, right? We teach that the inside lies, right? It's always opposite of what you feel like should happen, right? X plus 2. Instincts tell you that positive numbers are to the right. However, the function is actually going to move left. So all the x's are going to shift to the left. 2 spots, 2 units. So every point is going to go left. All right, so here we have the function and it stayed the same shape. It just shifted left 2 units, right? Everything shifted left. All right, number 2. Here we have x minus 2. Again, inside lies, right? So x minus 2, we're shifting to the right. All right, so that's what this one looks like, shifting right. Okay, number 3. Here's a little more interesting one. We're multiplying the x by 2. So remember, inside lies, right? When you multiply something by 2, instincts tell you that it's going to get doubled, right? You're going to multiply by 2, it's going to get bigger. Remember that, again, the inside lies, right? The inside lies. So it's the opposite of what you think is going to happen. So if we think that it's going to get bigger because we're multiplying by 2 because it's inside, it's actually going to get smaller. It's going to compress, right? It's going to shrink. Shrink or compress, however you want to think about it. So the analogy that I used last time, remember that so you have to think the horizontal direction. Everything x related is horizontal direction. So we're going left and right, right? We're shifting left and right. We're stretching and expanding, right? So if we're stretching horizontally, it's getting wider. If we're compressing horizontally, then it's getting narrower. And then any reflection in the horizontal direction is going to be about the y-axis, right? It's going to reflect about the y-axis. It's going to turn this way. All right. So let's see if we can wrap our heads around what's happening. So in this one, I would use the table like a couple times just to emphasize what's happening. All right, so at x equals negative 2, right? At x equals negative 2, we want to multiply 2 times x, right? Because that's what's happening, 2 times x. So negative 4. All right, negative 4, that's my input, right? That's my input. we have to plug in -4 into the function. So at x equals -4, where this is x equals -4, the y value is 3. So that is the value that I want. That's the y value I want, is 3. Now, we could have used the table and said, okay, at x equals -4, y is 3, right? At x equals -4, the output is 3. So we could have used that also, but I'm just using this one right here. Okay, so what I'm getting at is that x equals -2, y is going to equal 3. So at x equals -2, y is equal to 3. Now notice what happened with the point. It got moved towards it shifted, the point moved towards the y-axis. Or if we look at the next point, I guess you could say, would be x is equal to -3, right? At x equals -3, which is on the x-axis, right? So essentially what's happening is that whatever the x value is, it's getting divided by 2, right? Because here we had -4, 3. If we divided this by 2, the x value that is, we would get -2, 3. And that's exactly what's happening here. Right? All the points, all the x values are getting scaled by 1/2. Now it's like, well, why 1/2? Well, it's because it's the opposite of what's happening here, right? This is being compressed by a factor of 2, right? Compress by, by a factor of 1/2. Right? It's actually shrinking right now. This is getting compressed by 1/2. So what we want to do is take all of our x values and just divide them by 2. So for instance, so now that we understand what's happening, all the x values are getting divided by 2 from the parent function. We don't necessarily need the chart anymore. So watch. The next known point is on the x-axis right here. So this point is x equals -1, 2. So -3, 0. All right, where's it going to end up? That's the question. What's the new point going to look like? Well, if we divide it by 2, we get -3/2. So 1.5, -1.5, 0. That's the new point. Can I see where this is going? So the next point we want to look at, this is -2, -3. So -2, -3. Where's the new point going to be at? Well, we scale x by 1, right? By 1/2. So we divide by 2. So -2 divided by 2 is actually -1. So the new point is going to be at x equals -1, -3. All right, the next point, 0, 3. Find where the new point is, we divide it by 2. And this is going to be, again, 0, 3. So right now we learn that the y-axis, points on the y-axis are unaffected by horizontal compression and shrinks. But they're unaffected by compressions. All right, let's see the next point. So this is going to be 1, 1. So to find out where the new transformed point is, we divide by 2. So x equals 1/2, y equals 1. The next point, this is 2, 2. So divided by 2, 1, 2. 3, 0. Again, divided by 2, this is 1.5, right? 1.5, 0. And then lastly, 4, -2. So when you divide by 2, we get 2, -2. Connecting the dots. All right, connecting the dots, we see that it takes the original function and it squeezes it, right? It shrinks it and compresses it by a factor of 2, or 1/2 rather. It cuts it in half. It cuts all the x values in half. So we can say this compresses by a factor of 1/2. All right, number 4. If multiplying x by 2 shrinks it or compresses it, then multiplying by 1/2 will surely stretch it. Right? This is, again, you got to think opposite. All right, so every x value will get multiplied by 2. And the y is going to stay the same. So here we have -4. -4 times 2, -8. All right, as you can see, it grabs the ends and it stretches it apart. Like it pulls it apart by a factor of 2. All right, number 5. F of x, or f of -x. Again, this is going to reflect, right? It's going to turn all the x's, it's going to change the sign of all the x's. So whatever the x is, it's going to change the sign. So what we say is that this reflects across the y-axis. So across the y-axis. So how's this going to look? So the first couple points. So this is going to be x is 4, y is -2. Okay, so basically it's going to be -4, -2. It's going to reflect it across the y-axis. It's going to make the x value negative. And the y value is going to stay the same. So it's going to just reflect the point across the y-axis. So it's going to do this to all the points. All right, so all this did was rotate it across the y-axis. So a horizontal reflection across the y-axis. All right, number 6, f of absolute value of x. So remember what absolute value does. Absolute value just takes the positive value of a number. Anything that is negative will become positive. All my negative x values are going to become positive. So what's happening is that if you look at the parent function, all the negative x values are these right here. Right? These are all my negative x values. These are essentially going to go away. So this is going to disappear and it's going to be replaced with all the positive x values. So essentially what's going to happen is that the graph that's to the right, this is going to get reflected across the y-axis. So let's make a note. So again, the absolute value will reflect only the positive side of the graph, right, the parent function, across the y-axis. So this is how it's going to look. All right, just so you can see it. It reflects just the positive side across the y-axis. That's really our reasoning. All right, number 7. Here we have multiple things that are happening. Multiple transformations, right? So we have 3 actually. We have a reflection across the y-axis. there's a shrink or compression by a factor of 1/2. And then we have a vertical shift up 2 units. Okay, now you can do this in whatever order, as long as you do it correctly, right? But there is a system that if you follow, it'll be right every time. So if you reflect first, then compress or shrink, and then shift. So if you shift last, that will typically make this come out right. Now, again, you could shift this however you want or in whatever order, and it may or may not come out right. But I promise, if you follow the particular order, reflect, shrink, shift, or reflect, compress, shift. Compress and stretch are synonymous, right? It just depends on the problem. Then this will come out correct. So all right, so if we look at the first point, first we're going to reflect it across the y-axis. So it's going to be reflected across. All right, that's not its home. That's just the first thing that's happening. And now we're going to shrink it by a factor of 2. So we're going to divide it by 2, the x value that is. So 4 divided by 2 is 2. And then lastly, it's going to shift up 2 units. So notice what happened. The first point reflects across the y-axis. Then it compresses towards the y-axis, right? Because it's getting smaller, it's getting compressed by a factor of 2. So you're cutting it in half, or by a factor of 1/2 rather. You're cutting it in half. And then you're shifting it up 2 units. So this is going to happen to every point. These 3 things in this order. I'm not going to do it for all of them, like spell it out, but I'll do one more just so you can see. So the next point, we're going to reflect it across. So 3 units. And then it gets cut in half. So 3 divided by 2, 1.5. Shift up 2 units. So the green is where we're ending. The green is where we're ending. You really need to see all these. All right, so hopefully you can see where it's clear that it was reflected first, and then we compressed it by 1/2, and then we shifted it up 2. Okay, so hopefully that helps someone. Catch you guys in the next video.